So this is a second type of division problem. We said that there's two types of division problem. One, like the one that we just did, is that they ask me for the number of friends that I can share my candy with. This second one goes kind of like this. It says Marta has 20 crayons that she wants to share equally with 5 friends. So now they're giving me the relationship already. I have 20 crayons and I want to share those crayons with 5 friends. So my relationship in friends and crayons. Crayons and friends. No. The problem is that she has 20 crayons and she wants to share the crayon with 5 friends. It's not that each friend is going to get 20. The problem says that she has 20 and she wants to share those 20 with 5 friends. So she has 20 crayons and she wants to share with 5 friends. That's the way that is written in the problem. So the question is, that's exactly, well, let's see what the problem says, what the question says. Look at what the question says. Is how many crayons, so I need to know what the number of crayons, how many crayons will each friend get? So that's the, exactly, because I want to know how many crayons is she going to give to one friend. Notice that here in my relationship, I don't know the one anymore. That's what they're asking me. How many are in one? Unlike this problem that they gave me the one, and I like the multiplication problems that they all gave me that one. The division, there is one part of the division where they're asking me for that one group or one thing. Okay? So my table is, my relationship is between crayons and friends. The problem says that I have 20 crayons to share with 5 friends. How many crayons can I give each friend? Okay. So if we work in a multiplication problem, I would say I always start with 1. The only problem is that I don't have the relationship with 1 in the crayons, because that's what they're asking me for. So, if I cannot go from friends to crayons, because I don't know that relationship, I can go to the side. Remember when we did that in equivalent fractions? When we work in equivalents, if it did not work one way, you could also work it through the sides, right? This is what we did when we work on equivalent fractions. So I'm going to use this same idea for my division problem. If I can go from one friend to the number of crayons, because that's what the problem is asking me, I can still work with 1. So how would I go from 1 to 5? Times 5. But can I multiply this number times 5? No, because I don't know. But just like in the other problem, can I go from friends or from 5 back to 1? Yes. Doing what? Dividing it by 5. 5 divided by 5 is 1. And can I divide 20 by 5? Yes. So 20 divided by 5 will give me that number that I don't know. Well, I don't know yet because I haven't solved it. So, to figure out how many crayons will each friend get, I'm going to divide my 20 crayons divided by my 5 friends. Okay? So, again, to build my model, I'm going to use what I know. What is it that I know? What do I know? What do I know? Grecia, what do I know? Juan, what do I know? Okay, but what information in my problem I know? 5 is what? 5 is what? Juan, Luis. Okay, so I know my number of friends and I know how many I want to share. I don't know how many each one is gonna get. You don't know how many each one is gonna get. But I do know I have 5 friends, so I'm gonna draw my 5 friends because that's something that I know. I have 1, 2, 3, 4. I know my 5 friends. And I know that I need to share 20 candies. So how can I do to make sure that all my friends receive the same number of candies? Okay, so my 20 candies, I start giving 1 to each one until I get to the 20. And that would tell me how many each friend will get. So if I have 20 candies, so I got 1, 2, 3, 4, 5. Can I share more? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There we go. So now I'm going to go back to the question. How many candies will I give to each friend? So one friend is gonna get 1, 2, 3, 4. So it's 4. Each friend will get 4 crayons.